Hello, we are Innovative Waste Solutions from Florida Atlantic University. Today, we will be presenting our cost-benefit analysis, comparing the use of landfill gas collection systems with a renewable natural gas plant and utilizing source-separated organics in a composting operation. Our design team consisted of myself, Tyler Owen, Alejandro Vega, Arifa Sultana, Jonathan Lash, Eliani Lignelli, and of course, our advisor, Dr. Bisha Shaha.
All right, thank you, Tyler. So just some background information before we go forward. The county that we're dealing with in this situation is located in the United States Upper Midwest. The county in question is known to have a large agricultural industry, and also has an existing landfill that is set to reach maximum capacity by 2032. And given our problem statement that we need to decide the best way to dispose of organic waste, these aspects will be important in determining the economics of the situation that we are given. Now, these two alternatives to pick the best way to dispose of organic waste is either we collect the landfill gas and transfer it to a renewable gas plant, or we source separate the organics for a composting operation. One of the aspects that we need to keep in mind as we go forward is the amount of emissions from landfills that this produces. According to the EPA, municipal solid waste landfills are the third largest source of human-related methane emissions. So environmentally, this is going to be a major aspect that we will consider going forward.
Before the analysis could be done, background information on current technologies and existing sites utilizing these technologies was collected by all team members. Next, the economic feasibility of each alternative was estimated based on our findings and different EPA cost models, which will be discussed later. The environmental implications of each alternative were then investigated using the EPA's LandGEM software. The team considered all aspects of the respective project alternatives and determined the design considerations that must be made for implementation. This information was then used to conduct a cost-benefit analysis on each alternative, ultimately coming to a conclusion for the best project for our county. The criteria considered in our cost-benefit analysis included economic, environmental, and social factors. The capital investment and operational costs associated with each alternative were determined along with the investment projections and job generation. The environmental factors focused on in this study included landfill gas emissions, indirect greenhouse gas emissions through fuel aversion, and land conservation. Intangible factors such as community perception and the sustainability of the project was also determined to be as important as the aforementioned factors and was therefore included in this study. The EPA's LandGEM software was used to determine the landfill gas emissions from two scenarios. Historical waste disposal data from the county of interest showed that the average annual increase in waste generation was roughly 3%, and organic waste constituted 34% of the county's municipal solid waste. This data was then used to estimate the waste generation rates for the following years, which would be considered for our study. The first scenario considered in LandGEM was the baseline scenario, in which no organic diversion plan was implemented and waste generation continued to increase by 3%. The second scenario included the source-separated organics program. Implementation was assumed to begin in 2025 at an initial organic diversion rate of only 15%. Through community outreach and education, 5% increases in diversion rates are expected every year until reaching 90% of organics diverted by 2040. LandGEM's calculations determine the baseline scenario is expected to release 5.17 million metric tons of methane in 58 years, while the source-separated organic scenario is expected to release only 1.57 million metric tons of methane in the same amount of time. The reduction in methane emissions alone is equivalent to 104.7 million metric tons of carbon dioxide equivalent, or 11.8 billion gallons of gasoline. By diverting organic waste from landfill, we can also extend the lifetime of the landfills, in this case, by 9 years by our calculations. The EPA's LFG Cost Web Excel program was used to estimate the feasibility and cost of a landfill gas collection and renewable natural gas plant. Using the baseline waste generation, a design flow rate of 1,223 cubic feet per minute was used. A number of key assumptions were made, including that the RNG customer would only be 5 miles away. Therefore, a 5-mile pipeline was included in the price of site development. It was also assumed that the landfill would reach a maximum capacity of 30 million metric tons, in 2074. The plant considered in this study purified landfill gas to 96% methane pipeline grade RNG, which could be sold with a D3 renewable identification number. It was found that an RNG plant would produce 2,448,234 gasoline gallon equivalents of RNG per year. Assuming the current average price of $2.50 per million BTU for D3 renewable fuel, this would result in $680,610 per year, not including the RAN sales.
In order to perform a successful cost-benefit analysis that is valid for both of the previously mentioned alternatives, the team came up with a scoring table, which gives a numerical value to the level of preference of each alternative, being 3 the highest and 1 the lowest. The 3 is the most preferred alternative, 2 it's acceptable but not the best one, and 1 is the least preferred alternative. This will help the team find the level of suitability of each proposal. Also, for the performance of the cost-benefit analysis, 2 main criteria were identified. The first one is an economic comparison, and the second one is a social and environmental comparison. Each of the criteria have sub-criteria. Under economic comparison, we can find the capital and operational costs, the investment projection, and the employment generated. And under social and environmental comparison, we can find the social support, the emission reductions, energy savings, and the landfill lifetime.
The economic part of the project, if we talk about the net present worth, this value that we have was calculated based on a period of 30 years. The salvage value estimated was based on the average market price, and we calculated all the operational costs up to the year of 2025. Landfill gas to renewable natural gas has a net present worth in millions of dollars of 16.5. The score assigned was 1 because this is a comparison, and if we compare to SSO to compost, the net worth for SSO to compost would be like 8.7 in millions of dollars, with a designated score of 2 because it makes more sense from the perspective of the economical part.
The team thinks that public perception and public acceptance is a very important factor when it comes to the implementation of the program. That's why we decided to conduct a survey to a group of 70 individuals. The results of the survey show that if the city were to implement a source-separated organics program for composting, that 84.3% of the population will be willing to participate, while on the other hand, 15.7% will not be willing to participate. And we want to mention that we send the survey to people from different backgrounds, including people living in Broward County, West Palm Beach, and we also had some people from outside the country. We had people from Brazil, El Salvador, among others. For the people that indicated that they will not participate in the survey, we asked them to please indicate their concerns for the implementation of the program. The majority said, which is a 43.5%, that their main concern will be the lack of time for separating the organics, while 39.1% mentioned that their main concern will be the odors from organic waste. On the other hand, 21.7% indicate that they are not interested in participating in the program because they are currently composting at home in a small scale. And 17.4% voted that they don't see a clear benefit from the program, which this only tells us the importance of running different educational campaigns before implementing the program in order to make sure that it's implemented correctly and that people understand the benefits that they're getting and how the process will work.
If we check the operational costs and revenues for SSO, we're going to see the composting asked for an initial capital investment of $4,800,000, around $4,800,000. But if we analyzed per year how this is gonna what this is gonna cost, the capital expenditure per ton is $82. There's also the total annual expenditure that will be calculated around and estimated around $3,800,000. Operational and maintenance per ton, $65 per ton. An important information as well is that the tons per year of organic waste available would be around 59,000, and the compost produced would be 16,000, around 16,000. This means a leverage on return of 18%. It's a good number. Very important subject is the lifetime of the landfills. So there's existing landfills and proposed landfills. We're talking about landfills that occupies a 250-acre area with a capacity of 30 megaton. The current operations average leads us to understand that the useful life of a landfill like this is around 48 years. With our first alternative, producing natural gas would actually reduce it to 43 years. But our second alternative, that it's the composting, can increase the lifespan of the landfills to 52 years. The score assigned for the first alternative, the landfill gas and renewable natural gas is 1, and for the SSO to composting, it's 2.
The conclusion about in this project is that the criteria of weight and depend on the project, local population and public health. Yearly revenue from RNG and RIN sales was estimated to total 9.6 million per year. This is the annual operating cost and slowly paying back the large investment. So for the composting is that the total capital cost required to purchase composting equipment, develop the composting site, hire employees, waste collection trucks and supply bills is total around 8.6 million, while the annual operational cost is estimated around 4.3 million. So we recommend that continue to current as a cost. Every project is mainly focused on fulfilling 3 spheres of sustainability scope. 3 spheres are environmental, social, and if one project satisfied these 3 criteria, which is called sustainable intervention. The project. Environmental sector focus on environmental management, pollution prevention, economic sector trying to minimize profit, cost analysis, economic growth, and R&D. Lastly, but not the least one, social sector go good for standard living, education, community enhancement, and others. Again, we recommended that food separation organics for composting is good for this project. This figure shows that we collect food waste from different sectors like restaurant, household, and other sectors. And also we collect yard waste. We can convert these waste into aerobic and anaerobic process. So anaerobic process, we can divert this waste into biogas. We can use this biogas into vehicle fuel, increase electricity grid, and also we can use this gas into our household. And the aerobic process, we can convert this waste into fertilizer. So fertilizer, we can use this into the land. So again, we recommended that source separation organics for composting is good for this project. So this figure shows that scoring for LFG and RNG plants, and we get total 37 score for LFG to RNG plants. And this figure also shows that scoring for source separate organics to composting operation, we get 41 score for this composting operation. And the final one is that further recommendation. The implementation of SSO program in commercial and residential purposes is good for in this project. Optimized collection system is that collect food waste efficiently and make more money from it. Diverting all food waste in Florida has a potential power which can help 321,000 to 1110,000 homes. It's a big potential for us, to be honest. Willingness to pay higher rates to compensate for losses. So yeah, that's it. We can go through the composting is good for this project. So yeah, thank you.